Yeah, I'm Diego. I'm one of the dev advocates at SOS, working with Jason and Titus and Nikolai and Marcus, in case you have seen them. I'm also part of the Selenium team and one of the leads over there. So let's get started. The first thing I wanted to cover is why do we want to, optimize the execution speed in our tests? And basically, it's all about feedback, right? We want to understand much faster how our application is doing, which will enable us to get a better time to market. Here is what I want to start giving you all the context I want to share. If you are someone who is dedicated to write tests for a long time, and you know how the web have evolved from those monoliths to these modern web frameworks and so on, you see that traditionally our test automation strategy looks like this. I'm going to take as an example the Sauce Labs demo website. This is the previous version. I didn't take screenshots for the new version, but it applies. It's the same concept, the same idea. It's a website that you have different users. Depending on the user, you have different functionalities. Maybe you want to, I don't know, you want to have a user that shows errors. You want to have a user that works everything well. So we created this application as a way to demo Sauce Labs and as a way to practice test automation. So if you were someone who wants to test this application, what would you do? The first thing is clearly I want to test the login. I want to be able to differentiate that each user has different features available when they log in. So what do? You create one test for the first user, and then you create another test for the second user, and then you create more tests, and eventually you end up with 6, 7, 10 tests for every single different user. And you create also scenarios for wrong password, wrong user, etc., etc. So you create a set of tests and you write them and you execute them. And in this case, as an example, you have 6 test cases that will run one after the other one. Let's imagine that our website is used by a diverse set of users. They use all browsers out there. For example, they use Chrome, Safari, Edge, and Firefox, and we're lucky to have a good user base, and they use 2 different operating systems. They use Windows and Mac OS. So we start getting a matrix in our heads. How many tests we have, how many browsers we have, and how many operating systems we have. We end up with something like this. We only have, 6 tests, which give us 7 configurations. So we have the 4 browsers that can run in macOS, and then only from those 4, 3 of them can run in Windows because Safari cannot run in Windows. So that's why we have 7 configurations, 6 test cases. When we do the matrix, we end up with 42 test cases. And since we're opening a browser for every single case, and we're testing a bunch of things in every test, optimistically, we end up with a test that lasts between 1 to 2.5 minutes. So that's a lot of time. It could be between, like 50 to a bunch. I forgot my math right now, but a very long test suite. So one of the things here, this slide was misplaced. I'm sorry about that. So some years ago in 2019, there was a SOSCON conference, and Richard Bradshaw did an excellent talk that will serve as a source for our set of tips for today. Richard was talking that pyramids are old, that many people try to use this approach as a way to understand how to plan your test strategy. Like at the top, you have like the UI test, and in the middle, you have your API tests and all these things. And then he also was telling that some people invert it and you have the cone. So in some way, there is a lot of theory about that, And having said that, he tried to show us how this concept is still valid today in the face of modern web frameworks like React, like Flutter, like Vue, and so on. So what does this mean? Most of these slides are credited to Richard Bradshaw. This is very similar to the presentation he did a few years ago, and this was, yeah, like 4 or 5 years ago, and the concept still applies because testing so applying these concepts are still valuable in these days with modern frameworks. So what we're going to have here is this flow that we're talking about, and we're going to define different checks that we have and different actions that we can do. So at the top level, we have the UI test. You can either use something like Selenium, Appium, or with other tools like Playwright or Cypress, you can do that. But there is a lower level of the application that you can test with something like Jest, which is helpful for like unit tests in this case. Then at some level, at some point, the application will connect with the backend, and usually we use an API. The API connects with the application, with the backend, and most of the time there is a database at the end of all this. So on the first situation, at the UI level, we open the browser and we open the URL. We go to the website where the application is running, right? Afterwards, we decide in the test what we're going to do. Are we going to log in? Are we going to click here, etc., etc.? What happens after that action is that we render the browser is rendering what we're doing, and then we show the result of that action at the UI level. Then we continue. We send an API request because we want to log in this case. The API, the request goes all the way to the API, and then the application is verifying that the user is valid, that the password and all that, and returns a token for the session that we want to have during the time we're going to be living in the application, right? So there is a response, the response is verified, and then we decide to render the new view because obviously at the beginning we're at the login page, and after successfully logging in, we're going to be at the user page or perhaps at the catalog page, right? So the new view is shown to the user, and this is the flow we're having. So we have a section here that there is an action in the upper part. There are also a set of actions in the lower part. So there is something happening in the UI. There is something happening at the browser level. There is something happening in the API, in the application, and also in the database in most cases, right? What we're doing, what we're touching most of the time with the UI tests is these upper two layers. We're able to understand how the browser is rendering the application, and we're able to understand how the requests are coming and going from the browser as well. So our strategy needs to be understood at this level, right? Because I'm going to go one slide back. You can split your strategy in two different ways. One is taking care of the UI part, and then there is another part you can attack, which is all the API and application tests. So unit testing, API testing, and so on. And in many cases, this is the first step. At least this is what I saw in previous companies when I was doing actively testing. We had an API test suite, and we had a Selenium suite with several tests. These were separate teams, and eventually, in one of the internal meetings, we realized that some of the tests we were doing with Selenium at the UI level were also done at the API level. So there was a duplication of tests because most of the time the flow you go through the API is very similar to the flow you go in the UI level. So we started to compare them, and we started to realize, okay, it's enough to have some of this in the API, and we could delete some of these UI tests to make the test suite much faster. So we're going to focus on this part, but remembering that there is a bunch of actions that we do at the API level that could be done in the API testing layer. And here we could, for example, mock the API to make those tests run faster. So in this case, uh, we're going to focus on the part that we can control, which is the web framework that is being used to render the application. I'm saying we can control because I'm assuming that maybe some of you work in the same team the development team is doing. If not, you can also share these practices with the development team of the web application. So we're going to talk a bit briefly about JavaScript unit testing. And the idea is that many of the new frameworks have tools within them that help you do, I'm going to call a generic term of unit testing, but several things fit into this area. For example, if you're using React, there are different ways to do component testing, which is like something in between the unit test and the integration test. It's not really all there, but there is a way to test the different views of the application much faster without the need of spinning a whole browser. So the points about unit testing is that you can actually reduce in a great percentage the creation of bugs. And this also splits the amount of tests you have. The more unit tests you have, the less tests you will have at the UI level, because this will help you understand better if a change is going to break something sooner rather than waiting for the whole UI test suite to be complete. And then this is helping you also to make your application more testable, because if you cannot test something at the unit testing level or component testing level, this means that you will have more troubles trying to test this at the UI level. Many frameworks have tooling that enable you to run all these tests right after you save the file. So you make a code change, you save the file on disk, and all these tests run again. So it's pretty fast, really quick feedback, and this is a way to shorten the cycle of tests. And when you want to do refactoring, of course, it's much easier to understand if the refactoring is breaking something or not, because all these tests are serving as a safety net, sorry. Yeah, and as I said a moment ago, you can have less UI tests. Some practical examples here. For example, in the code, if you go to our repository in the Sauce Labs GitHub organization, there is the Sauce Labs web app demo that you can see the code over there, and you will see that depending on the type of user, we have different behaviors, right? So one approach would be the traditional, to create one single Selenium or Playwright or Cypress test for every use case that would need a browser to be open, to go through the whole flow, which is a bit exhausting sometimes. It's hard to debug. But what if you wait until that moment? Because, you don't wait until that moment to do all that tests in a browser, and you go a bit, you get closer to the code, which you see that in every single input, there is a method that is handling the input values. So in that sense, you can, for example, see that the code that is handling the value, you can see, okay, there is a way to test this code earlier and not wait until we have to write a Selenium test, for example. And if we keep moving, we see different return values from the methods that are validating the users, and then we can use those values as assertion values, or we can use them as precondition if we want to test the happy path or the path that doesn't work for the user, right? So we see the different users, and then we can create a bunch of unit tests. 6 years ago, this was annoying because you had to write every single test. Today, with the AI tools that we have around here, you can actually share the code and ask whatever ChatGPT or Gemini or whatever tool you're using, GitHub Copilot, you can ask them, please create for me a bunch of unit tests that cover this set of features. And this makes our life much easier because we just need to review that these tests are doing what we want, and we just start running them. moving forward, the same thing, like we want to verify credentials, we want to see if the user is logged out, we want to verify different features, right? And as I mentioned a few times already, you can do this with a browser, test the whole workflow. But in the end, when you get a failure because something changed in the code, you have to wait a long time until you figure out that specific error in the pipeline, because the developer has to commit, they have to push, they have to start the build, you have to do deployment to staging or dev environment or whatever you have, or start the Docker container if that's what you're doing, and then you can run the Selenium test. If you had a unit test next to the code that has been changed, you could detect that in less than 10 seconds, for example. In the end, what you're getting is a much faster testing suite that is helping you to cover and assure that the application is still working well. We need to stop thinking that the test suite from the testing point of view is just the UI part. It's the whole thing, the unit tests, the API tests, and also the UI test as well. And let's not forget about the component tests. So we can see that we can also get things like coverage, we can also think like timing. And if you compare the time all these tests need is much, much smaller than the ones you need at the UI level. So we need to rethink the UI test, right? Like if we have a good coverage in the component and unit testing level, then we're not going to have this situation where we have like 6 tests covering every single use case at the UI level with 4 different browsers and 2 different operating systems, or maybe 3 if you want to add Linux to this mix and match. And this is the situation we were having a moment ago. If we think about this approach, we're going to probably end with less tests. We're going to have a quicker way to run our tests because they're going to be less, still with the 4 browsers, still with the 2 operating systems, but we're going to have something that is going to be like just 21 tests. And since we're focusing on specific things, because most of the other things we want to test are being covered in component tests and also unit tests, we need to test like a less wide or a narrower set of features at the UI level. So in the end, this is more about understanding the strategy to make our test suite faster. For example, you will still do manual testing because you can do like exploratory testing to discover different things at your application, and the way that you have to maintain less tests at the UI level is going to give you time to do this as well. Since we were checking the different levels where the application is interacting, so the different stacks, so the UI, the application layer, the API, the backend, and so on, then you can understand that the application needs an API to work, and you can learn how this API works, and you can mock it, which will make your tests run faster. So one small parenthesis here is that I'm not telling you all that the way you have to go is to actually write a bunch of unit tests and more component tests and delete half of your UI tests. I understand that this might be very complex if you have a huge set of tests, but you can take different bits of this strategy and apply to your own use case depending on your current context and situation. For example, if you're still having I don't know, if for you like touching the code base and write unit tests is very complex, maybe you can focus on the API test part. You can mock the API and use API mock servers to replace the API and make your tests run faster. You can also go to the network layer, and for example, if your application has external dependencies, like for example, Google Analytics, let's say that your application, every time it's deployed and then it starts up and you load it, it sends a request to Google Analytics. You can use some networking tools like in CDP or in the future BiDi to block those requests and let your test and application focus on the right things for that moment. And in the end, if you go scaling up in this strategy, the idea is that, for example, you start doing this end-to-end testing, because at some point you have to test the whole stack with APIs and so on. But for that, you will not need a large set of tests. You can focus on like the most important workflows and run them on, like real browsers, real devices, and make sure that those things are going to work well for your customers on the real context and scenarios. And in some cases, it's very annoying to write a test and assertion for every single thing that we see on the page. And a way to reduce the amount of tests and optimize the test speed is also to look for something that does visual testing. There are many open source tools that are good enough, but there is also some paid tools like the ones we have at SOS that could be a good option for you to cover more of the application with less written tests, to cover these different features that you have in your application. In the end, to start wrapping up and opening it up for questions, the key thing is to do parallelization in this case. And the most simple equation we have is this one. Like if you have 100 tests and each test is 1 minute, then you have to wait for 100 minutes because you only have one single thread. Obviously, you have to invest in making those tests work in parallel. You can use a framework that supports that out of the box. You can obviously avoid test dependencies to make them work nicely. But as well, one of the key things here is to understand the tool that you need to choose to make them work in parallel. If you choose something like WebDriver.io or a tool that has parallelization embedded, it will make it work right away and it will make your life much easier. And yeah, something I was forgetting to say. One of the key things, if you run everything in sequential order, I mean, it's really easy to debug. And then if you refactor things to get this scenario where I have seen commonly, like people are very proud to say, I have a very small test suite. I only have 20 tests that cover all the things I need. But then you go and read every single test. It's like, I don't know, easily 100, 150 lines of code that they're doing so many checks in the application that is just exhausting to, one, wait for the test to be done, and second, debug it if something fails. Yes, the test suite will take less time because you have more VMs, because you have less tests, but then you just have to wait for a long time to see where the test is going to fail. And then you have to figure out what was the state of the application, what was the state of the test when it failed. So long tests is an anti-pattern. The idea would be that you mix and match all these things we have been talking about, that you mock an API, that you find a way to intercept calls that are not needed, that you make your application leaner, that you talk to the developers to find a way to make it more testable, that you are more unit test and component test. So in the end, maybe you have 100 tests, but each test is so small, so easy to understand that it will take 1 minute or even less, including the time it takes to launch the browser and close it. And if you have 100 VMs, then you will take just like 1 minute to run the whole test suite. And this is the idea, because if you have a small test suite, even a small test, even if it's like 100 tests in the test suite, it's rather easy to debug it, because you don't need to go through 150 lines of code. You just need to go maybe around, I don't know, 10 lines of code to understand where the failure was happening. So we need to have tests that are atomic, so that they can run by themselves. They don't need to, so they have like a small set of instructions, that they don't do a bunch of things, that they just focus on a simple goal. And we need tests that are autonomous, that we don't need a test that has dependencies on other tests. In the example of Java, for example, you have like TestNG, JUnit, and so on. TestNG has a feature, and I think the unit as well has a feature that I really dislike, that you can make a test depend on another test. So the other test needs to run first, so you can run the test you want. And I really dislike this feature because you're making your tests depending on each other. And this is an anti-pattern because ideally, if you want to run things on parallel, the test should be autonomous, should be able to handle its like data setup and the cleanup and all those things. And it should focus only on the things the test has to do. And it should be quick. So we should avoid those like 20-minute tests where we're doing everything. So it's a bit connecting with the atomic idea that it should be quick as well. So the recommendation is that start parallelization as soon as possible. And when you start doing that, you will see hints of possible problems in other places that you can actually attack and find ways to solve them and then improve the speed of your test suite little by little. One key thing is that this is not something that you just like move a flag to switch something on and off and then it works faster by default. This is something that you start to analyze little by little in your test suite and figure out where you can attack things, where you can pin things, and what you can solve bit by bit. Having said that, yeah.